Good morning, everyone. Welcome back to our YouTube channel. Today I'm here to discuss about the lubrication analysis. In the last chapter, we have seen the formulation of lubrication, how it was formed, what are the constituents in that, and this chapter is all about the lubrication analysis. But however, the lubrication analysis is a big chapter, so we will discuss it in part 1, part 2. So this is the part 1 section. Here we'll discuss around 4 to 5 types of analysis. So before we move to the analysis part, we should know why the lubrication is used for. What is the function of lubrication? So basically, the lubricants we are using in every rotary equipments. The lubricants may be solid type, it may be liquid type. But we here discuss mostly about the liquid type lubrication. Lubrication also may be of semi-liquid type, semi-solid type, that is a grease. So if we see the function of lubrication, basically lubrications are used to control the friction between the mating parts. The mating part may be the gear to gear contact, it may be the rolling elements of the bearings. It also helps to control the wear and abrasion between the mating parts. It controls the corrosion of the moving part because where the lubrication flow, there is a reduction of chance of water contamination, which will help to prevent the corrosion. It also controls the temperature because the lubrication take the temperature of the mating parts. When the mating part met each other, there is a friction, so there is a temperature. So that temperature is taken by the lubricant and it is being cooled through the PHE, plate heat exchanger, or tube type, cell type heat exchangers, and the cold oil is again circulated to the system. So by in that mean it controls the temperature. Then control the contamination. You see, when there is a rubbing between the mating parts, if the oil film inside the mating part is not sufficient, then there is a chance of elimination of the metal particles. Or you can see in the system, if your equipment is working in the dusty environment, and in that dusty environment, if you see there is a contamination of dust, outside dust particle, and this dust and the wear out particles are taken out by the lubricants and it is being filtrated outside in the filter, and again the fresh oil is going to the system. And lubrication also used for the use to transmit power. And the magic is here. If you see, the magic is the formation of oil film. You know, in between the mating part there is a very thin layer of oil film which is taking care of all the above functions we have discussed. So we see this is all about what is the function of the lubrication. Now we see why oil analysis is required. If we do the analysis in proper time, we can take in the preventive measures and we can save the spares which are having very huge cost. So you see, oil analysis is must because oil analysis is most protective maintenance technology. If you see, oil analysis predict the fastest damage of the equipment, and by doing this oil analysis we can able to know whether there is a metal wear out, there is a chance of wearing damage in the future, and accordingly we can take the proactive action. So you see, the cost of oil is very less in comparison to the cost of the spare parts use. So if we analyze the oil in proper time and we take the record of that oil analysis, and accordingly we'll take care of the machine parts so we can reduce the cost of the spare, which is very high. And you see, a 10-degree rise in temperature of oil double the reaction rate of lubricant, which decrease the lifespan of lubricant also. So this is why we need to do the oil analysis. So now we see how oil analysis can be done. First of all, to analyze the oil, we require a well established lab which is well equipped. Well equipped means for analysis several types of machines required, several apparatus required. So well equipped means most of the equipment should be there. Then the best part is that the staffs must be experienced and well trained, and your lab must be recognized by a quality control program. So you see, if all this setup is available with us, we can do the oil analysis properly. And basically, if you see a proper analysis of oil, the first step is the oil sampling. If we do the oil sampling properly, your accuracy of oil analysis will be much more. You see, physical analysis of oil will measure certain physical characteristics like color. There is a change in color of the oil. Oil may be basic in nature, acidic in nature. What is the level of contamination? You can check it physically also by naked eye. However, if there is a contamination, how we come to know that that contamination is the wearing contamination? It is the wear out chips from the bearings, gears. How we come to know? You might have know the MOC, that is a material of construction of the bearing, gears, internal housing. So when we do the elemental analysis of the oil by spectrograph, we can able to know what is the percent of metallic element and what type of metal element coming out, and accordingly we can take the pre-active measures. So here, this analysis report, what we are analyzing here must be compared with the baseline information available with us. So here we know how the oil analysis can be done, and how to achieve best oil analysis. We should there is a, and you must be enthusiastic to know how to achieve best oil analysis. If you want to take the best achievement, the best part is when you come to know there is a reduction of operation and maintenance cost, then you think that you achieve the best oil analysis part. And this best oil analysis can be achieved by establish a consistent oil analysis baseline record, by selecting test type from its applications, selection of proper sampling points. As I said, if your sampling point is good, then your accuracy in oil analysis will be also very fine, very nice. So you also, sampling interval plays a very vital role, because equipment to equipment, where the heat is more, where the contamination is more, where the environmental condition is bad, there you have to select the proper sampling interval. Sampling interval, that's why plays a vital role. So this is all about how you achieve the best oil analysis by watching the reduction of operation and maintenance cost. So now, in oil analysis, what we are doing? Oil analysis means, suddenly you can say there is an analysis of the oil. Okay, there is an analysis of oil. Then what are the test parameters? We have to see in the oil analysis, we have to check some parameters. So let us see what are the parameters. First of all, the physical appearance. The physical appearance means if we see the physically the lubricant, there might have some color change, there might have some other sort of changes from where we can able to recognize whether there is a deterioration of oil quality or not. Then second one is smell check. If you take a smell of that oil, there might have a acidic type oil, sour, pungent type, rotten type smell, then you can able to know the contamination level. Then third type may be change in color, which is a part of physical appearance, you can say. Fourth is viscosity, and this viscosity is of basically two types. It may be absolute viscosity, it may be kinematic viscosity. And fifth one is moisture contamination. It may be tan, Nash value, element analysis, which will give you the ferrous, whether the contamination is ferric in nature, or whether there is a copper, there is basically in elemental analysis will check the contamination elements, what are the elements available there, from where we can able to know the contamination is from bearing or from gears, from housing, or from any other mean. Okay, the last one is the suit. So as I already said, this chapter is very huge, so we'll discuss only the first four test parameters, and later on we'll discuss in the second chapter the next one. So now you see the magic, the physical appearance. As I say, you see, this is the oil, and oil, water are immiscible, so easily one can know, oh, here the water is contaminated with the oil. Heat, the second thing is the heat. If heat is added to the oil, you can easily know, yes, this oil may be burnt, the color of the oil changes. If oil is contaminated with oxygen, then oil is an acidic in nature. And basically the metal particle, if contaminated, it is easily distinguished, because definitely it is coming in terms of debris, you can say slurs, like that. So when all these four parameters mix with oil, the formation of acid is there, and hence the oil is corrosive. And due to mixing of all these things, the viscosity also changes. There is an increase in viscosity because the level of slurs, varnish, and tar increases. So this is the, if you will further discuss about this physical appearance also, because physical appearance means only you see the physically you can see the change in color. I will give you some examples, because we can easily distinguish the oil by watching the color, its appearance. If the color changes, I will give you some examples. Color change, you see, this is a viscosity grade 32 oil, and you see the new oil color is slightly pinkish. However, this is the old oil, it is blackish in color, gray in color. So there is a huge difference. But the thing is that if it is engine oil, it is recommended to right away change the oil. But in case of industrial hydraulic oil or gear oil, it is not recommended to replace. We have to first see the cause, why the color changes. There are different regions of color changes. It may be loss of lubrication property, it may be huge contamination, it may be aging of the oil, there may be thermal stress, that is due to heat. If the oil is subjected to high heat for a prolonged time, there is a chance of change in color or maybe oxidation. So only after analyze all these five things, we have to decide whether the oil should be discarded or it can be reused by some filtration, or by some type of method we can adapting to get the oil quality back. So color change in industrial hydraulic oil and that in combustion engine are two different things. As I said, in industrial sector, color change cannot decide that whether you are going to discard the oil or not. But in the engine oil, which is used in the automobile sector, if there is a color change, physical appearance can directly is a deciding factor to replace the oil 100%. So I'll give you some more photos here. You see the change in color right away. You can see. The second type of parameter is the smell check. Smell check, from the word itself, you come to know, you see, from the smell, how it is, how it feel, how you can say, what is the smell. If it is a little bit acidic in nature, there is a smell of rotten egg type, pungent type, then you can come to know that oil is a little bit acidic, and that means the tan number increases. And tan number, what is tan number? These are all will be discussed in the next session. So you see, so here from the smell we can come to know whether the oil can be replaced or not. You see, the changes in order can be due to the aging factor, due to the thermal burn subjected to high temperature for a longer period, due to oxidation. So this smell check also is a determining factor to know what all about the oil analysis. Now you see, the fourth one is change in viscosity. So as I already said, viscosity are of two types. It may be absolute viscosity, it may be kinematic viscosity. So viscosity of oil, you know, that stickiness of the oil, the resistance of the flow, that is nothing but the viscosity. But normally the viscosity is measured at a 40 degree centigrade temperature. And basically you should know there are basic parameters which influence the viscosity a lot, like temperature, pressure, degree of contamination, the degree of moisture, and the chemical changes in the oil and the shear. So as I said, we'll see the types of viscosity and how it will be measured. And first we'll measure the kinematic viscosity by capillary viscometer. You see, this is the capillary viscometer, and here there is a start mark and there is a stop mark. When oil drop down from the top and it reaches the start mark, there we have to start the stopwatch, and when it reaches at the stop mark we have to trip that, and we have to check what is the time. That time is known as the efflux time, and when this efflux time is multiplied with the this apparatus constant, we get the kinematic viscosity. So this is all about kinematic viscosity. And you know, this kinematic viscosity can be measured by centistokes, and absolute viscosity is measured. There is another unit, that is poise or centipoise. So absolute viscosity is normally preferred for the analysis of used oil. Okay, so when we convert this absolute viscosity to kinematic or kinematic viscosity to absolute, the main parameter is the specific gravity, and that time we have to take the specific gravity in both of the cases at the same temperature, because viscosity is usually depend upon the temperature. Normally we take the viscosity at 40 degrees centigrade temperature. While the temperature increases, viscosity decreases, and it decreases to a great extent. So you see, this apparatus is used to measure the absolute viscosity, and this apparatus is the rotary type viscometer. So this is the rotary type viscometer. Here we measure the absolute viscosity, which is much more preferred. Here, what happened? The torque applied by the spindle to rotate the oil is the determining factor. Basically, when we rotate, and there you see the oil, the used oil is inside this glass tube, and we give a rotational motion to the spindle. What the force? If there is a degree of contamination is more, you know, the viscosity is more, and you need more force to rotate. So the level of force or level of torque applied will tell how much is the absolute viscosity. So this is all about the analysis of the oil. We will meet in the second session in part 2 once again. So bye bye. Have a nice day. Thank you very much.